Greetings and welcome to a series of lectures on equations and inequalities in one variable. In this lecture, 2.1, we'll cover linear and quadratic equations. Let's open up by starting to talk about what is a linear equation. Well, we're going to talk about a linear equation in one variable. And what it is any equation that you can put in the form of ax plus b equals c. But very importantly, a, b, and c are all constants. They're all real numbers, and a cannot be 0. If a is 0, well, then we just have b equals c, and, well, therefore, 3 equals 3. That's not very exciting. But when we have a variable in there, that changes what the expression can be depending on what the variable is. And if we're talking about equations, then we also need to talk about the solution set. What the solution set is all the values that when you substitute them in one at a time, it makes the equation true. We might have one value that makes the solution true. We may have two. We may have none. We may have a situation where it comes up where there is no true solution. And then we also have equivalent equations. Pardon me, getting over a cold. Equivalent equations are just two or more equations that might look differently, but they have the same solution set. So let's take an example. So 2x minus 5 equals 9, x minus 1 equals 6, and x equals 7. Well, they're all equations because if you ended up solving each one of these, especially the third, you can definitely see that x equals 7. You can see the solution set is 7. So let's put it in just for the first one. 2 times 7 is 14, minus 5 is 9, 9 does equal 9. So that is the solution for the first equation. If we put in 7 in the second one, 7 minus 1 is 6, 6 does equal 6, and then likewise if we put 7 in where x is, 7 equals 7. All of these are true. The solution set for all of these is 7. These are equivalent equations. They look very different from one another, but they are equivalent because they have the same solution set. When solving equations, we're going to work with two very important properties: addition property of equality and multiplication property of equality. For both of these, for any three algebraic expressions, we'll just call them a, b, and c. If you have one algebraic expression a equaling another algebraic expression b, then you can say you can add the expression c to both a and b, and they will be equal. So a plus c will equal b plus c. Likewise, we can use the multiplication property of equality, that if, again, a equals b, then we can multiply them both by c, and they will still have the same solution set. So ac will equal bc. So let's try an example. I want to find the solution set of 3a minus 5 equals negative 6a plus 1. And I'm going to use my addition property of equality as well as my multiplication property of equality to be able to solve this. First step is get your constants on one side, get all your variables on the other. You get to decide which way you move things. I'm going to go ahead and keep all my variables on the left-hand side. So I'm going to add 6a to both sides. Okay. That will give me 9a minus 5 equals 1. Well, there's more than enough on the left-hand side, so I'm going to go ahead and get rid of that minus 5 by doing the opposite. So I'm going to add 5, and I'm left with 9a equals 6. Both of those steps use the addition property of equality. So now I'm going to use my multiplication property of equality to isolate my variable a and indeed solve for the solution set, find the solution set. Right now I'm multiplying by 9, so if I divide by 9, to both sides, I will have A equals 6/9, but 6/9 can be reduced to 2/3 because 2 times 3 is 6 and 3 times 3 is 9. So my solution set is 2/3. Now, of course, my solution set could be as large as I want it because we found that 6/9 is also a solution. We know that 2/3 is also a solution. If I decided to say, okay, instead of 6/9, what if it's 12/18? That's also a solution. So I can have numerous solutions that all fit within these guys because with fractions, I have equivalent fractions. Let's work through an equation with fractions, but there's a couple ways that we can work with fractions. The first method, I'm just going to go ahead and keep the fractions as is and work with the problem as it stands. So let's go ahead and say 2/3 x plus 1/2 equals -3/8. And I'm still going to use my addition property of equality for this first step, but I do need to subtract 1/2 from each side. And because I have fractions, I do have to find common denominator here. And my common denominator is going to be 8. So I do need to change my subtract 1/2. And I need to change that to a fraction with the same denominator of an 8. And to do that, I have to multiply by 4, both to the denominator and to the numerator. So now I have -3/8 minus 4/8, and that will give me 2/3 x equals -7/8. Now at this point I'm going to use my multiplication property of equality, but I have a fraction, so I don't want to divide by that number. So I'm just going to multiply by the reciprocal, which is equivalent to dividing by a number. So if I do that, I'm going to multiply each side by the reciprocal of 2/3, which is 3/2. What I do to one side, I must do to the other side. The whole point of that was, say, 3 times 2 is 6, 2 times 3 is 6, 6/6 is 1. So on the left-hand side, I have 1x. And then on the right-hand side, I have -7 times 3 is -21. 8 times 2 is 16. So my solution set is 21/16. Again, that's just one solution. I have lots and lots of solutions because I have a fraction. I can write it multiple ways. The second way of doing this is to eliminate fractions. So let's go ahead and rewrite our problem. 2/3 x plus 1/2 equals -3/8. And if I want to eliminate my fractions, I have to do it in two steps. One is I'm going to find my LCD of my denominators. My denominators are 3, 2, and 8. And the first value that all three of them will divide into equally is 24. So my LCD is 24. My second step is to multiply each term by the LCD. We have 3 terms in our problem. We have 2/3 x, 1/2, and -3/8. We're going to multiply each of the terms by 24. So I'm just going to write a 24 next to each of the term to remind me I need to do that multiplication. Okay. So 24 times 2, I could do that, but there's no harm in reducing first. 3 goes into 3 goes into 24 8 times. So if I reduce that, it's going to be 8 times 2x. 2 goes into 24 12 times, so that's really going to be 12 times 1. And 8 goes into 24 3 times, so that's going to be negative 3 times 3. So already my problem has gotten a little bit more simple than having to deal with the fractions. 8 times 2x is going to be 16x. 12 times 1 is 12. Negative 3 times 3 is negative 9. Now I've eliminated fractions. Yeah, I have a little bit larger numbers here, but not to worry. I'm just going to use the math that I know to solve for my variable. Negative 12, subtract 12, and subtract 12 from both sides. I have 16x equals negative 21. Divide each side by 16. And therefore, x equals negative 21/16. Therefore, my solution set is negative 21/16. Same exact solution set that I had up on top, same exact equation, so I must get the same solution set, but just different method. Think of it as many roads to get to your destination. Ultimately, it doesn't matter what road you take, you finally get to your destination. Let's try another problem. This time, this problem has some decimals in it. And like fractions, we have two methods of working with decimals. The first one is keeping the problem as is. And we're going to just keep the decimals and work with them. So let's work through that first. So I have 0.06x plus 0.05 times 1000 minus x all equals 560. First thing I'm going to do is distribute that 0.05 to both terms in the parentheses. So 0.06x stays the same. 0.05 times the first term of 1000 plus 0.05 times negative x all equals 560. I'm going to go ahead and do that math. 0.06x plus 500 minus, because that's negative x, 0.05x equals 560. Okay. Now it might be a little bit difficult to see, but if it helps, hold your hand over the equal symbol and everything to the right. And look, is there anything on the left-hand side that you can combine like terms to make this side simpler? And we do. We have 0.6x and we have a negative 0.05x. So just to make it very clear, I'm going to rewrite this so all my x's are together. 0.06x minus 0.05x, pardon me, plus 500 equals 560. I can combine my x's. I'm not moving them from one side to the next. They're on the same side, so I'm actually going to do this math. So 0.06x minus 0.05x is 0.01x plus 500 equals 560. Now here's where I'm going to use my addition property of equality. I'm going to subtract 500 from the left-hand side, but what I do to the left-hand side I must do to the right-hand side. 0.01x equals 60. Let's use our multiplication property of equality. I'm going to go ahead and divide by 0.01, divide by 0.01, and x equals 6,000. So my solution set is 6,000. Okay. Either you can write it as x equals 6,000 or your solution set equals 6,000. Now let's try the same equation. This time, let's eliminate the decimals. So let me rewrite our problem. 0.06x plus 0.05x times 1,000 minus x, there we go, equals 560. Okay, let's just move that up a bit. Now the first step is going to be exactly the same. The reason why is because I need to separate all of my terms. And if they're not all separated, sometimes it's a little difficult to figure out what we're going to do next. So I'm going to go ahead and do that same exact first step. 0.06x plus 0.05 times 1,000 plus 0.05 times negative x equals 560. Okay, and now you can simplify it because I can do this little old math. So 0.06x plus this is 500 minus 0.05x equals 560. Now I'm ready to eliminate my decimals. Now you could have done this the first step, but let me figure out what I need to multiply everything by to eliminate decimals, and then I'll talk about why I'm doing it now versus right at the beginning. So here's how I figure it out. Here are my decimals. 0.06 and 0.05. Those are the only decimals that I'm worried about. How many decimal places does 0.06 have? It has 2. And 0.05 has 2. I have to take the largest number that I find. And here's what I know what I'm going to multiply it by. I say 10 to the whatever the largest number is, which is 2 here, equals 100. That's what I'm multiplying each term by. Okay. So I'm going to multiply by 100, by 100, by 100. Yeah, everybody gets 100. By 100. I could have done that up here, but when you have this extra parenthesis, you might accidentally give it to the x. So I don't want you to make that mistake. You could do it up in that first top line, but if you're like me and can make a mistake along the lines, just wait. Just do the distribution and maybe do it right here. Multiply, multiply. Or simplify those like I did first, and then multiply everybody by 100. By multiplying by 100, that just moves the decimal over to the right 2 places. That leaves me with 6x. Plus 500 times 100 is just 500 with a couple more zeros. Yeah, I know it's a big number, but don't worry about it. A lot of zeros there. And then that's going to be negative 5x equals 560 with a couple more zeros. Okay, this next step is exactly the same. I'm going to go ahead and get my x's together just because it's easier for me to see. If you don't need that step, then you don't have to write it down. I'm just reordering my problem so I can see it a little bit easier. Okay. 6x minus 5x is x. X plus 50,000 equals 56,000. Going to this time subtract 50,000 to both sides, and that leaves me with x equals 6,000. Same exact solution set as I got before. One is eliminating the decimals, one is working with the decimals. I do generally kind of do that first step, multiply everybody by 100, the very first step. But for this video, I wanted to work it through until I had just the single terms. That way it was a little bit easier to see what I was multiplying by. So how do we conquer solving a linear equation with one variable? So there's a set of steps that you can follow, and generally if you do this, you'll get to the correct solution. So step one actually kind of has three parts in it. First thing is you're going to use distributive property to separate all the terms. Then you want to consider, do you want to eliminate fractions, or if you have decimals, do you want to eliminate the decimals? If you do, go ahead and do that. Third is combine all the similar terms on the left-hand side and then combine all the similar terms on the right-hand side. At that point, your equation is probably at the most simple stage that it can be before kind of taking the next couple steps to solve it. Step two is you're going to use the addition property of equality to get all your variables onto one side and all your constants to the other. 3, at that point, all your variables here, all your constants on the other side, you're going to use the multiplication property of equality to isolate your variable. And the fourth step is actually to check your solution. You should put that solution that you found back into the original problem and solve it. So let's just show you a problem work through with all of those steps. So we're going to solve 8 minus 3 times the quantity 4x minus 2 plus 5x equals 35. First step, use distributive property. So I'm going to distribute this negative 3 to both the 4x and the negative 2. So x minus 3 times 4x minus 3 times negative 2 plus 5x equals 35. Did some math here, just multiplied through, so now I have 8 minus 12x plus 6 plus 5x equals 35. Now remember, step 1b was, hey, do we have any fractions? Do we have any decimals to deal with? We don't, so we get to skip that step. Let's move on to step 1c, which is add all the like terms we can on the left-hand side, add all the like terms I can on the right-hand side. Well, the good news is on the right-hand side I've got one constant, 35. I don't have to do anything to that side. But I do have quite a few. I have 4 terms on the left-hand side that possibly I can combine some. Just going to rewrite it to where the constants are together and the x's are together. So 8 plus 6 minus 12x plus 5x on the left-hand side. 8 plus 6 is 14. Negative 12x plus 5x is negative 7x. Okay, so I have 14 minus 7x plus 35. We are ready to move on to step C, addition property of equality. For addition property of equality, I'm trying to get all my variables on one side and my constants on the other. Well, on the left-hand side I have constants and variables, and on the right-hand side I only have constants, so it does make sense that I just move my constants over to the right-hand side. To do that, I'm going to subtract 14 from both the left-hand side and the right-hand side, leaving me with negative 7x equals 21. Step 3. Step 3, I want to isolate my variable by the multiplication property of equality, so I'm going to go ahead and divide by negative 7. Divide by negative 7 to the right-hand side, leaving me with the solution of x equals negative 3. But we're not done yet. We really should verify that that is the solution. So step 4. Okay. Step 4, I take the original problem and I found that x equals negative 3, so wherever I see an x, I'm going to plug in a negative 3. Negative, or 8 minus 3 times 4 times negative 3 minus 2 plus 5 times negative 3 should equal 35. So I have to follow my order of operations here. and simplify as best as I can. So 4 times negative 3 is going to be negative 12, and 5 times negative 3 is negative 15. All the rest of it is the same. Next step, I'm going to do what's inside the parentheses here. Negative 12 minus 2 is a negative 14. So I have 8 minus 3 times negative 14 minus 15 should equal 35. Let's do the multiplication here. Negative 3 times negative 14 is positive 42. Now I'm left with 8 plus 42 minus 15 should equal 35. Well, 8 plus 42 is 50, so I'm left with 50 minus 15 should equal 35. And 50 minus 15 is indeed 35, and 35 equals 35. So this is definitely a solution because we got a true statement at the end of all of that. I know it sounds like a lot to do, but sometimes it's worthwhile to check your solution. Make sure that you did all the math right in the first place. Now let's move on to quadratic equations. Quadratic equation is any equation that can be written in the form of ax squared plus bx plus c equals 0. This is in standard form. A, b, and c are constants, and a does not equal 0. Just like with linear equation, if a is 0, well, then that's just a linear equation, right? So we definitely don't want a to be 0. So quadratic equation in standard form, if I have a quadratic equation of 2x squared equals 5x plus 3, I can write it in standard form by getting everything off the right-hand side and leaving just 0 over there. 2x squared minus 5x minus 3 equals 0. And you'd use your addition property of equality. Minus 3 to both sides, minus 5x to both sides, and you get it into standard form. Likewise, 5x squared equals 75. So standard form, it would be 5x squared minus 75 equals 0. And then for x squared minus 3x minus 2 equals 0, well, the standard form is exactly the same thing. It's already in standard form. When we have a quadratic equation and it's in standard form, we're going to end up to try and solve it by factoring. And because of that, here's why we're going to do it that way, is because we have this great property called the zero factor property that allows us to actually solve for the solution set. So what it means is for all real numbers r and s, if r times s equals 0, if and only if either r equals 0 or s equals 0 or both equal 0. So here's what I mean. Let's say r equals 0 and s could be gobbledygook. 0 times gobbledygook is still 0. And of course, if they're both 0, 0 times 0 is 0, and that also holds true. All right, let's try working through the problem of x squared minus 2x minus 24 equals 0. First step is it in standard form? Yes, it's already in standard form. So I'm going to go ahead and factor the left-hand side. So if I factor the left-hand side, I'm hopeful that I can find two values. X times x will get me x squared, but now I need two values that multiply to a negative 24 but add to a negative 2. I know that to get to a multiply of a negative, one must be negative, one must be positive, and the larger number of the two is the negative number because the middle term is negative. So let's see, 12 times 2, no. 3 times 8, no. 4 times 6 will do it. 4 times 6 will get me 24, and the difference of 4 and 6 is 2, so I know 6 is my negative, 4 is my positive. Here's where the zero factor property comes in play. That zero factor property says that if either one of these values is equals 0, then this statement is true. So I'm going to break it apart and say x minus 6 could equal 0. That could be the one that equals 0. Or x plus 4 could be the one that equals 0, and I'm going to solve each of these equations for a solution. Plus 6 plus 6. Therefore, x minus 6 equals 0. My value is going to be x equals 6. X plus 4, well, I'm going to subtract 4 from both sides. And my solution over here is going to be x equals negative 4. And at this point, I want to check these values. I just want to verify, is it true in the original equation? So let's verify 6. When x equals 6, I'm going to get, let's see, 6 squared minus 2 times 6 minus 24. Does that equal 0? Well, 6 squared is 36. 2 times 6 is 12 minus 24. 36 minus 12 is 24 minus 24. And 24 minus 24 is indeed 0. So 6 is definitely part of the solution set. Let's try negative 4. So when x equals negative 4, we're going to get negative 4 quantity squared minus 2 times negative 4 minus 24. Does that indeed equal 0? Negative 4 times negative 4 is positive 16. Negative 2 times negative 4 is a positive 8 minus 24 equals 0. 16 plus 8 is 24 minus 24, and it's looking good. 24 minus 24 is 0. So both of these values are solution set, so they fit the solution set is negative 4 and 6. Most cases when we're going to solve an equation by factoring, we're going to follow these 5 steps. First, write it in standard form. You may have to manipulate your equation a little bit, but write it in standard form. Second, factor the left-hand side. Remember, you only have a 0 on the right-hand side, so factor the left-hand side. Step 3 is use the 0 factor property to set each factor to equal 0. And then step 4, solve the resulting linear equations and check your solutions in the original equation. Let's try to solve this problem following those steps. First step, put it in standard form. Right now it is not in standard form, so 100x squared equals 300x. First thing to do is subtract 300x from both sides. That leaves me a 0 on the right hand side, and I'm left with 100x squared minus 300x equals 0. It is now in standard form. Now I need to factor it using all my factoring know-how. First things first, I want to check out to see if there's a GCF, a greatest common factor, and it is. Definitely see 100 in the first term, and I see 100 hiding in the second term. I also see an x in the first term and an x in the second term. So if I pull out a 100x as my GCF, 100x, that leaves behind an x for the first term and a 3 for the second term. Now that I've completely factored my equation, I'm going to use my zero factor property to solve for some possible solutions. So I have 100x equals 0, or I have x minus 3 equals 0. For the first value, I'm going to divide by 100 both sides. Therefore, x equals 0 could be a solution. For the second problem, I'm going to add 3 to both sides, leaving me with x equals 3. Fourth step, plug it into the original problem and see if the solutions fit. Okay. When x equals 0, we love 0, it's going to be 100 times 0 squared equals 300 times 0. It's going to be 100 times, well, 0 squared is 0, equals 300 times 0. Well, 100 times 0 is 0, and 300 times 0 is 0, and indeed 0 equals 0 is a true statement. 0 is just a plain old number here. It's not anything really special. It's just a number like 1 equals 1. Okay. Now, when x equals 3, let's see if it is a true solution. 100 times 3 squared equals 300 times 3. I'm going to work with the left-hand side. 100 times 3 squared is 9. 100 times 9 is 900, okay, on the left-hand side. And 300 times 300 is 900. Does 900 equal 900? Yes, it does. So our solution set is 0 and 3 for our solution set for this problem. Let's try a little bit more complex problem. Now, it may look like this equation is in standard form, but it's not because it equals 4. I don't want the plus 4 on that side. I want plus 0. So, a couple things that you can do, but I'm going to go ahead and move the 4 over. So now I am left with x minus 2 times x plus 1 minus 4 equals 0. Now this problem is still not in standard form, so I am going to have to expand it and then combine like terms, and then that will put it in standard form. So let's distribute. X times x is x squared. X times 1 is x. Negative 2 times x is minus 2x. And negative 2 times 1 is minus 2. And don't forget this minus 3, or minus 4 hanging out there. Okay. Now I'm going to add any like terms that I can. I have no other x squared, so I'm left with x squared. I have an x and a minus 2x is a minus 1x. Minus 2 and a minus 4 is a minus 6 equals 0. Now it's in standard form. Now I can go back and factor it. You might be thinking, hey, but I was already factored. Well, no, because remember we have that 4 hanging off the end. All right, so let's go ahead and find. We know it's going to be x times x is the only way to get x squared using whole numbers. Negative 6. I need two numbers to multiply to negative 6, but to add to negative 1. I do know one is positive and one is negative. One is negative and one is positive. I also know that the larger number is negative because my middle term is negative. I'm thinking a 3 and a 2 here might work nicely. All right, so that's going to leave me now 0 factor property of x minus 3 equals 0 or x plus 2 equals 0. Okay. Solve each one individually. X minus 3 equals 0. I'm going to add 3 to both sides. Therefore, x equals 3. For x plus 2, I'm going to subtract 2 both sides. Therefore, x equals negative 2. Now let's go ahead and plug those values into the original equation to check our solution. Okay. It's a worthwhile step to do because sometimes, depending on what your problem is, you might run into a solution that actually does not fit your problem. right, I'm going to say when x equals 3, I'm going to get 3 minus 2 times 3 plus 1. All of that should equal 4. Well, 3 minus 2 is 1. 3 plus 1 is 4. And 1 times 4 is 4, and 4 does indeed equal 4. Now let's try it with our other solution of negative 2. So when x equals negative 2, our problem becomes negative 2 minus 2 times negative 2 plus 1. Does that indeed equal 4? Well, negative 2 minus 2 is negative 4. Negative 2 plus 1 is negative 1. Does that equal 4? Well, negative 4 times negative 1 is positive 4, and positive 4 equals 4. Therefore, both of those values are the solution set to your equation. Let's try another problem. 2x cubed equals 5x squared plus 3x. First thing you need to ask yourself, is it in standard form? No? Go ahead and get it in standard form. So 2x cubed minus 5x squared minus 3x equals 0 is in standard form. Now you need to factor it. Always look for GCF. Can you pull out a GCF? Once you have pulled out this GCF, is the remaining amount factorable? If it is, factor it. So I do have a GCF here. It looks like each one of these terms has an x in common. So I'm going to pull out the x, leaving me x times the quantity 2x squared minus 5x minus 3. Now I need to factor that second term. And I can factor it into 2x plus 1 and x minus 3. And you can work whatever way you like to work to find your factors, but go ahead and figure that out. Take time out, pause, whatever, and figure those factors out. This time, instead of just 2 factors, I have 3 factors. So using the zero factor property, I'm going to have 3 equations to solve. X, 2x plus 1, and x minus 3. Well, the first one's pretty easy. You set it to 0, x equals 0. You found your one solution. Or 2x plus 1 equals 0, or x minus 3 equals 0. Now I've already worked these out, so I'm just going to pull it down step by step. For the middle one, I have 2x plus 1 equals 0. I'm going to add 1 to both sides, and then I'm going to need to divide by 2 to solve for x. The third one, I'm going to have to add 3 to both sides, so x equals 3. So my solution possibilities are negative 1/2, 0, and 3. Sometimes your equation will have 4 terms on one side equaling 0. So it is in standard form as it is. But how do you conquer this? Think about your rules about factoring. And since we have 4 terms, you may want to try grouping. So that's what I'm going to do with x cubed plus 2x squared minus 9x minus 18 equals 0. And I'm just going to group it, the first 2 terms and then the second 2 terms. You can reorder it and try and do things that look similar, but I'm just going to go ahead and leave it as is and break those 2 apart separately. So x cubed plus 2x squared, I can factor that, pull out a GCF of an x squared times x plus 2. For the negative x squared minus 18, I can pull out a negative 9, leaving me x plus 2. Well, lo and behold, both of those have an x plus 2 in common. That's a common factor I can pull out, leaving me x plus 2 times x squared minus 9 equals 0. And at this point, you might think you're done factoring, but the x squared minus 9 is actually the difference of perfect squares, and I can factor that. So ultimately, I'm going to have three groups: x plus 2, x plus 3, x minus 3. Once you solve those, your solution set is going to be -3, -2, and 3. So we have three solutions. Here's a good kind of point of reference. In our original equation, we had x cubed. Our highest power was cubed. We should have three solutions. Now they might repeat, but we should have three solutions, and we actually do. -3, -2, and 3. Now we've chatted about all of these different examples that had solutions, but what happens if, well, we either don't have a solution or the equations both on the right-hand side and the left-hand side are exactly the same? Well, let's take an example. 2 times 3x minus 4 equals 3 plus 6x. Once we distribute the 2, we get 2 times 3x plus 2 times -4 equals 3 plus 6. 6 minus 8 equals 3 plus 6x. I'm going to get all my x's to the left-hand side, so I'm going to go ahead and subtract 6 from both sides. But 6x minus 6x is 0, and 6x minus 6x is 0, so that leaves me with -8 equals 3. And ask yourself, when does -8 ever equal 3? Well, it never does. It's false. Therefore, this equation has no solution, at least no solution as written. Let's try -15 plus 3x equals 3 times x minus 5. I'm going to go ahead and distribute the right-hand side. So I have 3x, 3 times x plus 3 times -5. That's going to give me 3x minus 15. And if you don't see it right now, both sides are exactly the same. But if you don't, keep going. Get all your variables on one side and all your constants on the other. So if I subtract 3x from both sides, that goes down to 0, leaving me -15 equals -15. Now ask yourself, when does -15 equal -15? Well, always. So all real numbers are solutions to this problem. I can put in any value for x, and it will come out to be a true statement. This is what's called, the original equation is called an identity, because the left-hand side always equals the right-hand side. And because that's always true, all real numbers are the solution. So that's it for this video. Till next time, be seeing you.